So we all ready to get started?
Yep.
All right. So there it is. Okay, so kind of by way of review of how we got to here, we've been working through the different major categories or major groups within ExcelerSize. So we talked about the business application components, which are the requirements and the pages and reports and so on. We talked about data conversion during the last module. And so this module, we're going to be talking about data warehouse. And then in the future modules, we'll be talking about project level and support. And then the final one that we're going to cover will be the modifiers. So that'll be quantity, area, complexity, work, and uncertainty. So in terms of data warehouse sizing components, the catalog elements that are used to support that are data warehouse specific are cubes or OLAP data marts, extract, transform, and load operations, portals, predictive models, universes, and then the supporting standard components. So we're not just going to use the ones above, but we're also going to use some of the standard ones as well. And so each of these are going to be discussed in more detail in the slides that follow. But first, at a high level, a data warehouse is a repository of extracted data that is used for reporting and analysis purposes. It's typically not real time. It can be close to real time, but those extracts that go into the data warehouse may happen on a daily basis, maybe over the, at midnight they run and they do the extraction. They could happen on an hourly basis. But there's normally some kind of a time lag, and you normally cannot assume that the data that's in a data warehouse is real time. Data warehouse has several advantages over direct access to production data for the purpose of reporting and for analysis. Data can be pulled from a variety of external systems and consolidated in the data warehouse. So let's say that you've got a new system plus you've got several legacy systems, and the data is somehow related. So what you'd like to do is have a consolidated view of all of that data. Well, rather than trying to rewrite all those systems to use a common database, what you can do is you can extract the data from several different systems and then consolidate it within the data warehouse. The data warehouse can impose a consistent data naming taxonomy without requiring changes to the source system. So let's say that you've got an enterprise data group that's defining your standard naming conventions, your standard data formats, how street addresses are represented, how long your account numbers are, and so on. You can use that standard taxonomy in the data warehouse without needing to change all the different source systems, and then do the conversions to the standard naming convention as part of the operation bringing the data into the data warehouse. Another advantage is that computer processing unit or I/O, input-output intensive queries are not going to adversely impact your production performance. Users, especially when they're given ad hoc capability, can inadvertently write some highly complicated report queries that involve sorting through and individually reading, let's say, all of the data records in a table. And so without really realizing it, they've done a query that doesn't even use, maybe it can't even be answered with the indexes. And so it's got to manually go through and read every single record in the in a very large table. And that process obviously involves a lot of input-output over the bus. It involves a lot of computer processing work. And if you're doing that kind of reporting against your production system, your production users or your production processes can experience a slowdown. So if you have a data warehouse, it eliminates that possibility. Another advantage of data warehouses is that your cross-platform or your system data relationships become visible to management. So let's say that we've got data in you've got accounting data and financial data in one system, and you've got sales tracking data and sales system and customer system data in another system. Well, the only thing you can, if you're only reporting against those individual systems, the only insight that you can gain is insight based on the data that's within that system. So in the financial system, you can gain insight based on whatever the financial data is. And the customer tracking system, you can gain insight into whatever the customer system is. But if you're able to pull those two together and join those sets of data, now you can gain additional insights because you can look at the financial history of individual customers and what general ledger accounts they're hitting and all kinds of questions that you might not be able to even ask as long as the data is separated. And then finally, data warehouses can insulate your production data from either intentional or unintentional contamination. So for example, if we have a situation where we're going to make some dashboards available for widespread use within the company or even available to the public. We're going to take this dashboard data, we're going to let people do queries and so on against it. It sounds like a great idea, but the problem is that a hacker can get in there and can get around some of your security perhaps and get back to that data and then either intentionally contaminate the data or get in there and extract things out of there or whatever. If that's your production system, once they're into it, they've got full access to all the data. Whereas if it's a data warehouse, the only thing that they're going to have access to is the subset of the data that you've published within the data warehouse. So it's a level of insurance against contamination of data. Now, walking through the ExcelerSize different sizing components, we'll start with cubes, or online analytical processing data marts, or OLAP data marts. Those are two words for the same thing. They basically are the same. So a cube is a multi-dimensional collection of data that is somehow related from a business perspective. So if we're looking at something like sales data, for example, or let's say revenue data, we're looking at revenue data. Well, one of the dimensions might be by branch. One dimension might be by region. One dimension might be by product. One dimension might be by owning vice president. So if you think about it, we have basically the same conceptual set of data. It's somehow related to revenue. But we have different dimensions that we might want to examine it based on, depending on what kind of report we're writing. So we would create this multi-dimensional cube that would have all of the different attributes of the data that we're interested in, plus the data itself, in this case, revenue. Cubes were created to allow business users to easily generate ad hoc queries and reports that would slice and dice the data in different ways. So once the cube is defined, you can just kind of publish it out there. And a business user can get in there with some drag and drop type tools. They can say, well, I want to filter it this way. I want to sort it that way. I want to total these up. So they can do all kinds of analysis work on it without needing to have the programmer involved at all. When you're estimating, you would normally assume that each logical cluster of relevant business data is going to ultimately be represented as a cube in the data warehouse design. So each category of data warehouse user is likely going to require at least one cube. So if you've got your sales team is going to be using the data warehouse, they're probably going to want at least one cube to represent the data that's relevant to them. If your financial folks are going to be accessing the data warehouse, they'll probably want at least one cube. So even before the design is done and you know how many cubes there are, you can look at the number of logical clusters of data, the number of users that are out there, and make kind of an educated guess about the number of cubes that will be required. An extract, transform, or load process, or ETL process, is how the data warehouse obtains the data from the source system. So an ETL process continues to run in production as opposed to a batch process that might run just one time. So let's say that we're extracting data from a source system. If that data extraction is going to run on an ongoing basis as long as the data warehouse exists, we would call that an ETL process. If we're going to write it as a one-time extract, let's say maybe because it's static data or it's historic data, then we would probably represent that as a batch rather than as an ETL. The ETL processes extract data with minimal involvement from the source system, as opposed to an interface that involves close coordination between both systems. So with these are all, and the reason I'm going into these distinctions is because they're all very similar, and the estimates for them are very similar. So if you get one off or one wrong, you're not going to be way off. But in general, it's better to try to use the correct object. So an interface, normally there's a lot of talking going on back and forth between the systems, or there's some error checking that's going on back and forth. There's it's kind of a structured data format that where both sides of the interface have to do perhaps some programming or have done some programming in the past. An ETL process, on the other hand, is normally done as a set of queries against the database itself. So it might involve the source system database administrator to do those queries, but it's not as much a program-to-program interface. It's more of a program on the data warehouse side to a data source or a persistent data source on the target side. The ETL process will typically need to do transforms. So obviously the simplest case is I'm going to go out to the database, I'm going to read in some data and put it in the data warehouse. So if that's the case, what we have is a very low complexity ETL process. But it's not unusual for the ETL process to need to do data transforms. So the kind of transforms that we're going to be looking for, we would be looking for in this, are cleaning. So basically what we're doing here is we're making sure that the data is meeting integrity rules. And if for some reason it's not meeting integrity rules, we're not allowing it to go in. So what we're doing is we're either correcting it, if we can correct it automatically, or we're typically putting it into a holding place where someone can manually go in and examine it and find out what's going on. A second thing that we may be doing is filtering. So we're looking at the data that's coming in, and perhaps we're only interested in a subset of the data for the data warehouse. So we would use these filters that are set up, and we would exclude some of the data that's in the source system from coming across into the data warehouse itself. We have validation, which is basically making sure that the data passes all of the validity tests. And validation and cleaning are related, but a little bit different. Cleaning is normally something that's done only within the scope of the data record that you're examining. Whereas validation, you can be looking across records. So for example, an example of validation would be I get a purchase transaction in. Cleaning would be looking at that purchase transaction to see if it makes sense. Validation would be making sure that the product that was purchased is in our product table, making sure that the customer that did the purchase is in the customer table, that type of thing. Another example is splitting. Perhaps in the source system, the data is not in third normal form, or the data is very complex. And in the data warehouse, we split that into third normal form, or we simplified the data in some other way. So what we're going to do is we're going to take a complex data record and we're going to split it into simpler records. Another example is joining. In that case, in the data warehouse, we may have data that's consolidated into one record. In the source system, it may be split across multiple records. So what we're going to do is we're going to combine those records and then put the combined data into the data warehouse. Another example is derivation. So in that case, what we're doing is we're using some kind of operation, for example, a mathematical operation, to create a new data field based on the existing data fields. So for example, maybe we're going to read in the data that's part of that of an invoice, and maybe the invoice data does not include the total amount, the total for the invoice. So what we're going to do as part of the ETL process is we're going to sum all the transaction data, and we're going to come up with a total, and we're going to write the total out to the database as part of our ETL. And then finally, we can have pretty much infinitely complex business rules that we apply as part of the ETL process to decide what we want to do. So those are going to include, obviously, you could write whatever rule you can think of. If it's Monday and it's a full moon, then we're going to add 3 to this field. So whatever basic business rules you can think of, you can add to your ETL process. For early stage estimates, you would normally assume that each dynamic, unique, relevant source table is going to require an ETL. So until you know better, later on somebody's going to be able to estimate how many ETLs there'll be, and if there's not very many of them, you'll have to assign a complexity, so you'll have to work with them in terms of complexity. Keep in mind the central limit theorem, which tells us that if there's going to be 30 or more ETL processes, we can call them all average. And really, you could probably get away with that perhaps as low as 15. But if you're only going to have 3 or 4 ETLs, you're going to have somebody help you figure out are they likely to be complex or simple. But for early stage estimates, you're probably not going to know how many ETLs there are. But what you will probably know is have some indication of how many source tables are going to be feeding into the data warehouse. And so you'll be able to, from there, say that, well, let's assume that there's 1 ETL per source table. The next data warehouse specific object is portals. So this is the number of portals to be implemented. And a portal is a user interface framework where user interaction components live. So it's basically like a home page kind of a thing where you could put individual subcomponents that have capabilities, that have interaction with the user. Normally, a data warehouse will require at least 1 portal. You would have multiple portals, typically if you have different categories of users that have different capabilities and different user interface requirements. So for example, if you had internal users of the data warehouse and external users of the data warehouse, there's a good chance that they would each require their own unique portal. If we had business users versus consumer users, there's a good chance that they would each require their own portal. So for here, what you're going to need to look at until somebody tells you otherwise is basically what are the clusters of users of the data in the data warehouse and how different is their interaction with the data warehouse going to need to be. And then you may need a different portal for each group that has a significantly different interaction with the data. Predictive models is the number of predictive models to be built. Each of the predictive models is going to accept some independent variable inputs. It's going to apply some kind of a model, which is normally some kind of set of mathematical formulas or something similar. And then it's going to generate 1 or more dependent output values. So it's much like we're doing with cost estimating. Examples of models include Bayesian statistical models, neural networks, genetic algorithms, power functions. We use a lot of power functions as part of estimating. So examples of business use include things like spam filtering, revenue forecasts, fraud detection, cost estimating. If we think about it, cubes look backward. What happens is when you publish a cube, you're allowing the user to go in there and look at historic data in different ways and understand that historic data better. Predictive models, on the other hand, they forecast forward. So a predictive model would look at that historic data and then automatically forecast revenue or forecast defects or forecast whatever else is going to forecast the probability that a given transaction is a fraudulent transaction. So anything like that, anytime people are talking about the ability to do forecasting, there's going to need to be some kind of a predictive model in the background that drives that forecast. Universes. A universe is a semantic layer that collects and defines the available data in a more business-friendly fashion. Its purpose is to shield the business analyst and the user from the details of how the data is stored. So if you think about the data is stored at a physical layer and the data warehouse database. And so there we have things like tables and we have field names and so on. Depending on the database, the field names, may not be super friendly. The structure is structured, perhaps it's optimized for performance. But basically we have the data stored in the database. We would like to have people who are writing reports and writing user interface screens and so on to be able to access that data and write their reports and design their screens in a manner that's more user-friendly. So we don't want them to have to worry about the structure of the data underneath. We don't want them to have to worry about the naming underneath. There may even be situations where the data at the field level in the database is more closely aligned with the source system data naming, and where the universe provides more of your enterprise architecture naming convention layer semantics. So it may be at the universe level where we achieve that. So basically the universe insulates the people writing the reports and doing the data access from the structure of the data underneath. A data warehouse will typically have at least one universe. It may have multiple universes. If there's fundamentally different types of data that are going to be accessed. For example, we may have commercial lending and retail demand deposits are two different clusters of data within the data warehouse. In that situation, it might make more sense to have that represented as two different universes, each of which is simpler rather than one much more complicated universe. The idea here is that you want to, the universe should simplify the underlying data. So you don't want to overly complicate it. So if somebody's going to be writing reports strictly for the commercial lending group, we would like the list of available fields and tables and choices and so on to all be specific to commercial lending. And we don't want to have them get confused by dropping in fields that have no relevance to them at all. So that's why we would create multiple universes in that situation. So I've talked about the data warehouse specific sizing components, but implementing or modifying a data warehouse includes both those data warehouse specific components, but it also includes all of the standard components. So for example, we're going to write reports against the data warehouse. We would use the report component. We're going to have pages that are used to access capabilities, for example, dashboards. We would use the page component. We may be writing batches for one-time static data loads or historic data loads. We would call that a batch. We may be generating alerts from within the data warehouse. We would probably call those services. We will possibly having workflows for task flows within the data warehouse. We would call those workflows. So basically the data warehouse is a functioning working computer application, and it's going to have access to all of the other ExcelerSize sizing components that are relevant for any other business application. The only difference is that a data warehouse has some additional data warehouse unique components that won't be found in other types of development. Some special considerations. The data warehouse normally operates in its own environment. If you think back to the earlier reasons for building a data warehouse, one of the advantages, a couple of the advantages were insulating your data from an attack or whatever, and not having production problem or not having CPU problems or I/O hogging reports slow down your production system. Well, if you think about it, that obviously implies that we would expect that the data warehouse will be running in its own environment, and that's normally the case. Your large ETL requirement, if you've got large ETL requirements, you may actually require a separate staging environment for the ETL processes itself. So if it's a large data warehouse and we're pulling in a lot of data from different systems and we're doing a lot of transforming on that data, that process itself can take a lot of work can be very CPU intensive, and we would normally put that in a separate environment. And then once the data is clean, then we would do a load to transfer it into the data warehouse. When you're looking at data warehouse estimation, you really want to make sure you understand the user roles of who's going to be accessing it. So, for example, the end user role in terms of what work they're going to do. So, for example, let's say we have a requirement for 25 reports. They're going to be generated using different queries, but on one cube. In one case, the project delivers the cube, and the end users create the reports. So in that situation, we have the cost of the cube, but there's no project cost per report. The end users do that, and whether they take a week to do it or whether they take 10 years to do it, it doesn't matter to us. In another case, after the cube is delivered, the developers are tasked with sitting down with the end users at a whiteboard or whatever and creating the reports on behalf of the users and then testing them to make sure they work and so on. So in that situation, each of those 25 reports would represent some project expense. And I think, yep. So before we get into the exercises, does anybody have any overview questions about data warehouses?
So William, this is Shannon. If I understood correctly, if you set up a new data warehouse, you have to have cube, at least one cube, at least one ETL, one portal, and one universe.
That's correct, assuming it's a new data warehouse.
Okay, so you don't have to have a predictive model per new data warehouse.
Right.
Okay.
Yeah, the predictive model would only be required if we're going to be doing, if anyone's going to be doing any forecasting. And it's not unusual for the initial implementation of a data warehouse to not have any predictive models. Quite often what happens is the first go-round at the data warehouse, in fact, it's not even unusual for the first one to have very minimal, like even in theory, you could say, well, you know what we're going to do is we're going to create a data warehouse, but as part of this initial go-round, we're not going to have any portals or cubes or anything like that. All we're going to do is we're going to extract the data and put it into a database. So that might, if you're doing this in a phased kind of a manner, that would be a logical first phase. And then once the data is all gathered together and understood, then the end users can get in there, and as part of phase two, they can define what dashboards do they want, what reports do they want, what predictive models do they want, and so on.
Okay, but there are a couple of those that have to be set up with the new data warehouse day one.
If it's going to be usable.
Okay, yeah.
Yeah, unless you're, but like I say, if you're doing it and where the first phase you have the data there, but it's not usable for business functionality, it has no business capability yet, then you wouldn't need it because it's only partially implemented.
Okay.
Anybody else? Questions? All right. So project one involves implementing a new data warehouse for the sales department, which is going to consolidate sales data from 10 existing tables. No other information is available. What sizing components would you use? So Shannon, I'll ask you to answer this one.
10 tables, 1 cube, I think. Is that not right?
I'm going to let you finish.
One 10 tables, 1 cube. Well, there's not any other information.
Okay. So when we don't know, remember, as estimators, our job is not to just look at the information, but our job as estimators is also to make educated guesses. So in this case, what I would say is we would make an educated guess that will end up with one universe, because it's the sales department, that will have one portal, because they'll want some way to access that data, with the user interaction. As you mentioned, they'll have one cube. They already have the tables. They're existing tables. So I would not call that 10 tables. I would call that 10 ETLs, because we're going to need to extract the data from those 10 tables, possibly transform it, and then bring it into the database. And then one environment, because as we mentioned earlier, normally a data warehouse is going to need to run in its own separate environment. Does that make sense?
Yeah, I just couldn't read through my 2.5 pages of notes that fast.
Oh, that's okay. That's okay.
Yeah, now that I look back at everything, yeah.
Yeah, okay.
It takes a little time to digest it.
Right. So student exercise number 2. Project 2 involves adding 5 new data extracts that are going to run on an ongoing basis and 5 reports to the previous data warehouse. What sizing components would you use for this change request? So, Michelle, what do you think?
5 ETLs, 5 reports, as long as they don't have like a portal already existing where they're pulling those reports themselves.
Mm-hmm. So what we probably have is we'd have the 5 ETLs for the 5 new data extracts. We'd have the 5 reports. We probably would need to modify that cube and probably need to modify the universe, because once we've added some ETLs, it's going to change the available data fields, which is going to change the universe and also change the cube. Everybody kind of follow that logic? So student exercise 3 involves extending the previous data warehouse to support the CFO's need for sales forecasts. What sizing components would you use? John, I'll let you get a shot at this if you want.
Okay. Would have one, extending the previous data warehouse. We would have one portal or one modified portal. Reports. And I'm looking through my notes as well. Well, extending, I mean, extending could also imply there's some additional ETLs needed, right?
Could be.
Okay, so modified portal, modified or additional ETLs, and additional or modified reports.
So what I would say is you're correct that the CFO might want a different portal. I'm not sure. It would depend. We'd have to check. It's correct that the CFO may need some additional ETLs, but I'm not sure. If the data that the CFO needs is already in the sales, is directly coming out of the sales data, we may or may not. So those are both judgment calls. I could see that going either way. What I do know we're going to need is a new predictive model. Anytime you see the word forecast, think predictive model. So if we're doing a sales forecast, there's got to be some kind of a model that looks at the historic data, does some analysis, and then forecasts the future data.
Forecast
forecast, and that's where the bulk of the work here is going to be. The bulk of the work is going to be defining what the sales forecast predictive model should look like. And then we'll have a report, could be a page too, but we'll have some kind of an output of the results of that sales forecast. Okay?
Yep, that makes sense.
Project 4 involves extending the previous data warehouse to support the HR department. They've identified 15 tables and 3 systems that contain data they are interested in. They've also provided copies of 5 government forms they want to automatically populate from the data warehouse. What sizing components would you use? Gail, you want to give a shot at this?
Sure, I'll give it a try. So it's supporting a new department, so I would say they would need their own cube because it's going to be a new category of user. Let's see. Tables, so 15 ETLs. I'd say 1 portal. Assuming there are different type of, let's think previous data. And then report or page. Copies of 5 government forms that want to automatically populate. So I'll say those are workflows. 5 workflows. That's what I got.
Okay, very good. You're very close. So I would call that 15 ETLs, just for exactly what you said. For the 5 government forms, I'd probably call those 5 forms -out. So remember from our very first lesson, we had forms -in and forms -out, which are defined as previously defined, fixed format forms, normally in PDF. They're going to be either take data out of the database to populate the form or take data off the form to read into the database. So in this case, what we're going to do is we're going to have those 5 government forms, which are obviously predefined. We're going to take data out of the database and put it onto the form. And then exactly as you pointed out, they're probably going to need their own cube, their own portal. I would also probably anticipate they'll want their own universe. So normally, because they're a separate group, I would think they'd want their own cube, portal, and universe.
Okay.
Okay?
Mm-hmm.
All right, and we're at the final 15 minutes or so I can open it up for questions.
Augustine managed to avoid a question again.
He's disappointed.
I was guessing. So, William, I had a question on the one before, the last one. So it's 15 tables, so it's 15 ETLs. Is that what you're?
Yes.
Okay.
Unless you know otherwise, you would always assume one ETL per source table.
Okay. I was doing 3 ETLs, I mean, one per system. I mean, assuming that I was combining tables in its system, but.
So that because there were 3 systems, that doesn't come into play at all. It's just the tables that we're interested in.
Yeah, exactly. That's part of the trick part of this question. When you're writing the ETLs, you're normally going to be dealing with different systems. So, and the number of source systems may in some cases have an impact on the complexity of an individual ETL, but would not impact on the number of ETLs. So let's say that I was doing one ETL and my source system was, I don't know, a simple database and access. That might be a low complexity ETL. It might be fairly simple. Let's say another one was a very complicated table structure and ISAM running on a mainframe. Well, that may be a much more complicated ETL, but it's still just one ETL. Any other questions?
You just answered mine. I was thinking about sometimes you may have multiple indexes on VSAM files in a mainframe, and you've got to get to that data. And you're right, you've got to, what you might normally have in one database or one table in DB2, you may have in multiple VSAM files. You've got to
exactly.
put that together, yeah.
And another thing, and this is more of a project management than an estimation thing, although it's kind of in the gray area between. Generally speaking, it's best to try to get the people who own the source data to be the ones who have responsibility for the extraction component of the ETL. And the reason I say that is because they're going to be the ones who are the most familiar with the data, the system, and so on. So they're going to be able to extract that data in the most efficient manner possible. If you think about it, when you've got your environmental settings and so on, the amount of experience someone has with the code base they're working with, and with the system they're working with, and with the data they're working with, has a big impact on their productivity. So ideally, when you're doing data warehouse work, you like to have a partnership with the source data owners where each of the source data owners will take on responsibility for the extraction component. That gives you the most efficiency possible. And then they'll be able to help guide you for, will this be an average or low or high complexity extraction?
Is it okay,
William?
Question about an estimate that we're working on right now, where we have an ETL layer?
Okay.
Or specific?
It's fine. Keep it. Don't get into proprietary stuff if you don't mind. Or if you do get into proprietary stuff, tell me and I'll make sure I edited it out.
All right, maybe I'll just have the conversation offline with John and Michelle.
Okay.
Because I'm not
let me
sure
ask a general question.
Say.
Okay, so what if we're going to add on top of the data warehouse some type of BI tool that would pull the data from the different data warehouses, something like that that can migrate many different sources, perhaps, Excel to actual data in SQL databases or in multiple data warehouses. How do we account for something like that? Because I often hear of work like that, like utilizing something like a MicroStrategy or a ClickView or some BI tool.
Sure. So basically a BI tool is, in effect, has a lot of the same characteristics as a data warehouse. So it's going to either extract the data from different sources and then do reporting on the extraction, or it's going to consolidate the data in place. But either way, it's almost doing the same thing. So if you think of ClickView, for example, ClickView extracts data and then stores that data in tables. So that table is basically a little mini data warehouse that ClickView then reports against. Even if it's just a dynamic table, like a pivot table in Excel, that's still kind of a mini data warehouse because there's still an extraction into the pivot table, and then there's transformation on the data, and then there's reporting on the data. So each of those has a lot of commonality, a lot of similarity to a data warehouse. Now, the other way to view it is you can also look at it as a commercial off-the-shelf software installation with configurable software. So if we're going to say, well, we don't really know what reports are going to run, we don't know everything else, but how much will it cost to take Oracle's BI tool, for example, and to install and configure that to be able to be accessing, 5 different databases around the system around. So there we're going to view that as a commercial off-the-shelf software installation, and we're going to look at the amount of configuration and modification work that's required to install and configure that COTS application.
Okay. So I guess if they have to do a lot of work within the VI tool to display a bunch of different information, to have a bunch of different graphical representations that are automatically refreshing based on, data like on some cycle or process, batch process, then we would probably need to look towards the route of software application. But if it sounds more like we just need a place to pull all the data together, that provides people a portal or a window to be able to pull things themselves, that might be more like some of the data warehouse components we talked about today.
Yeah, well, generally speaking, if we were looking at a fairly large effort to install and configure an off-the-shelf product, and at the time we're doing the estimate, we really don't know, we don't have a comprehensive list, or we don't really have a strong idea of who's going to use it, how they're going to use it, what they're going to do with it, and so on. I would estimate that as a configurable COTS application install. And so what we're doing is we're providing a baseline capability of whatever's built into that COTS application, and then maybe some budget for extensions to it, like with reports and so on. But so we don't really know anything else other than that. On the other hand, let's say that we had a simpler application, like maybe a ClickView, or that Oracle BI or SAP Business Objects or whatever was already installed. And so that piece was already done. And now what we're working on is the CFO has a set of capabilities that they want to add to that are going to involve access to the data and getting additional data into there and more data connectors and so on. I would probably use a combination of the data warehouse components and the business application components to estimate those pieces. That clear?
Yeah, I think it helps.
Okay. Other questions? Okay, well, thank you guys for your time. I will see you at the next session. Okay, thanks, guys.
How you doing?